just again to allow everyone to have a bit of this exercise and to reflect, I would suggest that you write down on a piece of paper or on your PC or whatever the trajectory that you think is the critical path, because then again we will go to the VUB lab and I will ask you to vote which one is the critical path. If you analyze the figure, what you actually see is that there are 3 paths throughout this project. You could go this way, 1, 2, and then 3, 6, 9. Which could be the critical path. This could be the critical path, or this could be the critical path. Yeah. Of course, in order to complete the project, you will need to execute all the tasks that are there. But the question is, which is the critical path? Which is that path where, as soon as you get a delay, you delay the whole project? So write down, I would invite you to write down that trajectory, the numbers of the tasks. So either you say 1, 2, 3, 6, 9, or you say 1, 2, 4, 8, 9, or you say 1, 2, 5, 7, 8, 9, or you might say, well, basically there is no critical path. Could also be an option. But write it down. I will give you a few seconds. And I still see some people writing, so I will wait. Yeah, I see people getting their cell phones. So at the same time, I will launch the question in VUB lab. Let's go to the next question. I will hide it. Voila. So the question is, which of the trajectories that you saw, according to you, is the critical path? Yeah. So the 3 trajectories or the 4th possibility, there is no critical path. And then we'll see again, wisdom of the crowd. There's in previous years, there was always a little bit of debate on this. So no worries if you deviate. The cardigan. Okay. Well, here's the trajectory. The interesting is once you know that critical path, you're also able to answer this question, the minimum execution time, and you're also able to answer this last question, the slack or the float. So that's why I asked for the critical path. Let's see how many answers we have. We have 22. Okay, we'll wait for 25, something like that, and then we'll see what the crowd tells us. One more vote, voila. I'm curious. Not too bad, well done. So the correct answer is indeed that received the most votes. It's the first one. 1, 2, 3, 6, 9. Because if you look at, whoops, I've hidden the slides. If you look at this one, so it's this one indeed, which is the critical path. Mind you, it's even not the path with the most activities. Like this path has more activities than this one, but the way how to calculate it is, of course, to look at the duration. And so if we look here at this path, we see that the minimum time to execute it is 4 plus 3 plus 3 plus 3 plus 3, which is 16. Those alternative trajectories, you can execute them in a lower amount of time. This one you can do in 4 plus 3 plus 2, which is 7, 9, 10, 13 units of time. So this one is shorter. And also this one is shorter because it's 4 and 3, which is 7, plus 1, 8, plus 2, 10, plus 1, 11, plus 3, 14. So this is the critical path. This sequence of tasks is critical for your project. And it therefore also already immediately solves that first question. It's that duration that path that determines the minimum execution time. You cannot complete this project quicker than 16 days. And then it's a bit of a pity that I also included the last answer already here. But once you know this, you can actually also calculate or reason about the slack or the flexibility that you have here. How would you do that here? Well, you know that this is the critical path. This takes 16 days to execute. You know that this one took 14 days or 14 units of time to execute. So that means that here we have this flexibility. We could basically say, well, here, those two tasks, because also 5 has that flexibility, we can shift from shift them earlier, shift them a bit later with 2 units of time. So 2 days, you can shift a little bit to the front, to the back. So visualizing activities in your project, such as your IT project, gives you already a bit of an idea. What are the critical items? What are the critical tasks into my project? And again, this constitutes a risk if timing is important. And so it could give you clues on how to mitigate those risks if you would find it necessary and appropriate. Questions about this? No? If you want, you can also come in the next break and ask some things. I know that sometimes not everyone can, or not everyone can grasp that from the first time. So then please don't hesitate to ask it. Yeah. All right. We're still in the planning, but no worries. The other phases, we will not take them so in depth as this one and the analysis one. And we're coming to the end of the planning phase. So we saw 3 techniques for planning: a work breakdown structure, the PERT chart, and then here we have a Gantt chart, which is very similar to the work breakdown structure. So it is a breakdown of the different tasks, but in this case, it will always include the duration, the expected duration of a task. So then the envisioned start and the end date. And this Gantt chart will traditionally also give you a view, a perspective on, okay, what is our intended planning? So we intend to do, whereas this gives you the options, this is already a plan, actually a proposed way to go ahead. And so you list for each of the tasks and the subtasks when you intend to start, when you would intend to end. And therefore, it's not only useful during the planning, but you can also use that Gantt chart in the case you would actually execute a project, because then you can draw this red line, which is the time or the moment that we are now, and you can see at this moment in time, normally all these tasks should have been executed. So you can check, are we on schedule or not? All those things should still be executed in the future. In your most optimistic case, you would even already be executing them. You never know, but it might be that you're running up front or behind schedule. Yeah? So that's typically the third well-known technique, and there are quite some well-known software packages which help you in creating those schedules and following them up. Yeah. Now, everything that we've just seen should normally then come together. That business IT alignment reflection, the scope document, the benefits, the costs, and so on, is something which is called a business case. So one definition for a business case is a formal document with structure overview of all the relevant information that you've gathered around the project, and it gives you a rationale, a justification. It's not just gut feeling. You have objective elements, factual elements that give you a justification to enable to start an investment. And in this case, it's an IT-enabled investment. So it's also necessary for those kind of investments. We see it now in the first phase, the planning. In an ideal world, you would also give it continuous attention. So not only at the start, but also in the next phases. If you are in the analysis phase, in the development phase, in the testing phase, and whatever, it's important that you maintain and review it. There might be new elements, new risks, new costs, new benefits, I don't know. But based on that new information, ideally you should update the business case and consider, is it still relevant for us to continue this project? We see that in reality, it's often not done. Often, hopefully, in quite some cases, something like a business case is made, and that's already a good start. But then often it's put on a shelf, it starts gathering dust, and it's not used anymore. In an ideal world, you do take it as an active document and you work with it and you review it. So what should then all be in that business case? As I said, everything that we discussed before. So the scope document, expectations, benefits, costs, risks, initial planning, and therefore the feasibility, everything that we have said there. Yeah. So just reiteration of before, it should be monitored for its relevance, for new information, and so on during the project. Ideally, at the end of the project, you again refer to that document that you wrote in the beginning, and you say, okay, the anticipated costs and the benefits, did we actually realize them? And even during the duration of the project, you should update it whenever necessary. That also means that, often things do not go as planned. As I said before, most plans are incorrect, and that's not a problem. You should have a plan to start for. Ideally, after such a business case, there will be a go, no-go decision from management. They will say, given all the elements that we have, do we have a justification for this project, yes or no? Ideally, that's based on factual elements. That's what often happens in reality. In an ideal world, you would also take the decision several times during your project, not only at the start. It might be that during your project, as I said, the planning was not perfect, new elements arrive, additional costs, additional risks, additional problems. Maybe the business has changed its approach, new strategy initiatives have arrived. And so the reality at day zero might not be the reality in 2 or 3 years. And then, the business case should be updated and the investment decision should be taken again. We already have invested money, but do we still want to invest further money, given or based on the new information that we have? What we see is that in reality it's not done, or if it's done, that people are often investing or inclined to still keep on investing, although rationally speaking, it might be good to kill or to stop their project. If you have done, or if you have an investment course, or if you have done some introductory economics already, you might be familiar with this expression because it's typically called like a sunk cost. People often have the tendency, I have already invested something in a certain project, and then it's psychologically very difficult to abandon that because you have invested in it and you don't want to leave it, you don't want to kill it. However, there might be rational elements where you say, well, although I have already invested money in it, rationally speaking, it's better to cut my losses and to stop than to keep on investing, not realizing my benefits, but just, not recognizing the reality and not daring to say, well, actually, it's better to stop and to consider those initial investments as lost. And some people also call this like black hole projects. So you keep on investing money and money and money, but they never really deliver. So that's also a very important reflection on this business case material. So coming to the end of this first phase, in planning, we will do all those things that we've just discussed. That also means that the artifacts, documents related to this phase are a scope document, cost benefit risk analysis, these initial planning schemes, and then all incorporated in the signed business case. As I said, at the end of this phase, management takes a go, no-go decision. If it's positive, the project is launched, stakeholders should be involved, and the management should show clear commitment to support the project, announce that they find it important, make all the resources required in terms of people, in terms of money, available. These decisions are often not easy because a lot of departments, a lot of teams in an organization might have ideas and they might want to execute something. So they come up with all kinds of ideas. There's a limited amount of money, there's a limited amount of time, there's a limited amount of people. And so decisions need to be taken. These projects we don't do, these projects we do. And then considering multiple alternatives, multiple projects to yes or no execute them, and that's then what's called program portfolio management. So often an organization will not only execute one project, they will have a portfolio of projects, and so they need to manage that. Yeah. Yes, please. Yes, we will come back to that later on. I mentioned like in the initial second slide that this is one way of doing it. pedagogically speaking, it's very easy to explain it like that. At the end of the session, we will see that there are some alternatives to that. Okay. All right. Planning done. Now the analysis. Analysis is what one of your colleagues also mentioned. It's like putting the needs or formulating the needs for this project, not at a high level that we did during the planning, but in a more specific way. You will dive much deeper into those requirements for the project. So that's really the goal of the analysis phase. What is the specific functionality of the system? What should that system do? We will also discuss quite some things here, because just as with the planning, the analysis phase is really relevant for this audience because it's really at the border between business and IT. It's not only responsibility of business, but it's also not only responsibility of IT. This is really where both worlds come together. The goal of that analysis phase, by specifying the requirements for a system, is really to become a domain expert, to really understand how does the universe of discussion, as it's called, the world we are looking at for this system, that the system needs to support, needs to automate, whatever. How does that world work? How does the domain work? And we need to become an expert into that. There have been some authors who have said, well, what are actually good, or what are the quality criteria for such an analysis? What should your function analysis meet in order to speak of a good function analysis? And of course, it's already quite some time ago that it was formulated, but it's still relevant. Some of them are now a bit taken for granted, and of course, in most cases, those things, they will be electronically stored, but all the other ones, they are still relevant. So if you will ask a project manager or an analyst, what does a good function analysis mean? He or she will mention things which you see on these slides: ambiguous, complete, correct, understandable, verifiable, consistent, both internally and externally, concise, no redundancy, reusable, very organized, cross-references around all the place, and then the question is, does this look easy? And I already saw some people laughing. No, this is a very hard job. It seems difficult to say, okay, tell me what the system should do. In reality, this is super, super difficult. So no, it's not easy. Given the fact that it's not easy, we cannot avoid it. We should do our best, and we should try to get as far as we can. So the first thing to do, or first way to tackle that, is to look at all the relevant stakeholders that might provide you a little bit of information on that. Could be external business users like your suppliers. Maybe they give you information on your supply chain management system. For sure, internal business users, your own people who do the process that you maybe want to support or automate on an everyday basis, they might provide you some information. Your customers, maybe, what do they expect? What is the service that they want? Executive management or regular management might have some requirements on that. Technical people, technicians as well, they might have some good ideas. They might have some relevant points there. So the first step would really be to have a cross-stakeholder consultation to really say, okay, let's generate some ideas here. What are the things that we need to consider? During these discussions, as I said before on the former slide, what's important is that we check, are all these requirements consistent? Are they exhaustively? So do they cover everything? Sometimes it happens that users do not really know the requirements. So you cannot only look at the business users. Sometimes people are a bit stuck in the way how they have been doing something for years, and they take certain things for granted. And so that's why it's very relevant to also talk with other stakeholders, because they can think a little bit about out the box, and they can also give you new views and new perspectives on this domain that we need to become an expert about. We have different people. We also have different sources. Suppose that you would be running around in an organization that's building a certain application. What kind of material would you look at? What kind of things would you look for? Okay, you will consult a lot of people. You might talk to them, but what are other things you might do except for talking to them? Market analysis, yes. Sorry? Finance, yes. What kind? But within that market analysis or within finance, what kind of things would you look for? What kind of things would you ask for? Resources, number of people, yes. Servers, well, what we often see is that those analysts, what they will ask is they will indeed they will ask for numbers, for market studies, or whatever. They will ask for any kind of document sometimes that already exist, digitally, non-digitally. We see that in a lot of organizations, things like forms and procedures, they exist. If they already exist, it gives you a first clue of how the organization works. Because apparently, if you want to start something, you need to fill in a form that already says something, for instance, about the information that is required in the IT system. If there's a certain procedure that tells us first this needs to happen, then this needs to happen, then we decide A or B, and then we continue, it already gives you an idea of the different steps or different actions that need to happen. Could be inside the company, could be outside the company. You need market analysis, but also standards. So some industries, they have standards, ISO standards, for instance. They might be a good input for your analysis because they might put requirements on you that you need to comply with. As I said before, you can have interviews with stakeholders, can be one-on-one. You could also use questionnaires, so a list of questions that you share with a bigger audience. Also interesting to do is to literally run around in the company to do observations. Even if you have interviews, even if you look at documents, a lot of things that happen in an organization are what they are called tacit. So they are not documented, and people will even not tell you them because they take it for granted. They find it super evident, super logical that it's there, and therefore how good willing they might be, they will not tell you because they find it self-explanatory, and often it is not. So one of the good ways to avoid these kind of assumptions, these hidden assumptions, is to actually ask someone, can I join you for a few days on your job? I will not do anything. I will maybe ask you some questions, but I will just observe you as you work. And I will observe the things that you do. Apparently this person every day in the morning, he starts by going to the warehouse and noting down these things. And then based on that, he will take a decision and he will call that person these kind of things that they might not tell you because they find it, of course, I mean, I'm putting the order, so of course I should know what's in the warehouse. Well, for that person, might sound very logical. For the analyst, might not be so. So you observe what's happening, in which order, what kind of information is consumed, is created, and so on. You might go one step further. You might create workshops or brainstorm meetings where you not just have one-on-one meetings or observations, but you put a limited amount of people together and you ask them some intriguing questions. What is the vision of our company for this element or for this element? Or suppose that you have carte blanche, you can choose whatever you want. What would you like to achieve, and so on? We could use those group decision support systems then that we talked about last time, and it could also solve you to solve some contradictions. Because what will happen if you have questionnaires, interviews, observations? It might be that some people do a certain task different than other people. It might be if you ask them, that person A will say, this is very critical for the system to do it like this, and another person will say, no. The good way to do that is this. So you get some, obviously, you get some differences. But when implementing it into a system, often you don't have resources to implement several variants. You will need to go for one. And so some of those workshops, they will allow you to discuss those differences, to come to a consensus, to make some kind of a common process to agree upon. It also helps it to generate a bit of enthusiasm, momentum on the project. What is also very useful is that if you're in a situation, the possibility of creating prototypes, so a very first version of the system that's not finished yet, but it can give an idea to people what it might look like, what it might do, that makes it very tangible to people. No. We missed this information, and so this information should be added. Or no, the system is completely not doing what it should be. The output should be different. Things like that. So you have intermediate versions that you can use as the starting point of your discussion, and people give very direct feedback to what you're doing. Of course, as we discussed last time, you are not always in the luxury. In a lot of cases, there will be a situation where you will not just build a system from scratch. where you say, well, based on our risk cost benefit analysis, the market and so on, our internal resources, we will need to go to buy an existing package, which is out there. So as I said before, one of the strong points of these existing packages is that often they already have processes embedded in them. So then one way to go ahead with your analysis might be, okay, we take that existing package, we look at those processes, and one by one we screen, is this something that happens in an organization? If so, how? Is it the same? Is it not the same? And you start building up that functional fit analysis that we talked about. So different people, stakeholders you need to talk to, different sources of information that you can get. And so at the end of that analysis, you need to come up again with some artifacts, with some documents, with some outputs. There are many kind of documents and outputs that can come from the analysis phase. I've listed 3 most common ones. The first one are use cases. We will discuss them in a minute. And then the other 2 ones, data models and process models, well, they are actually 2 of the techniques that we will discuss in the practical sessions 6 to 8. So what does a software system do? Well, it takes data as input, it does something with that, and it provides data as output. You need to put that into a model. You need to work with that, and often what helps to be very unambiguous, very clear on what you want, to make sure that business and IT people understand each other, is by using models, graphical representation of things. They will force you to include certain things. There are some kind of standards, some kind of agreements between people, like a box here means this, or an arrow here means this. And so graphical representations of certain aspects of information systems, data and process elements will be built. And that's the typical output of an analysis phase. So for more details, let's see the other lectures later on. One of them I will briefly discuss here, and these are use cases. Also, use cases are a very interesting output of the analysis phase. What is a use case? A use case is defined as one of the activities that the system performs. Something that the system should do, typically requested by a user. So it's something that the system should do one way or the other. And it's as it said here, it's triggered. So there's a certain event that causes the system to do something at a specific time, specific place. So that event can be external. The user wants to look up something external to the system. Can be time related, every Monday, every week, whatever, the system does something. Or it can be an internal state. The system detects that the stock is below X, so we need to place a procurement order. What the use case then will do is it will say, well, at this event, the system should do something, and it will describe the interaction with the system. So if a user wants to look something up, it will say, okay, if that's the case, a user wants to look up something, that's the event that takes place. How will then the interaction between that user and the system happen? So that use case will describe how that interaction happens. It will not tell you how the system should do it. So it only focuses on the interaction system user, not the details of how the system should actually do it. That's for later on. In a lot of cases, this is put in a visual representation. Here you see for an ATM, an automatic teller machine, a cash system that you see. Okay, you see some users, which are typically represented by these little people that you see here. And so they are customers, could be a bank customer, or could even be a maintenance person, and they interact with the system, with the ATM, for instance, by withdrawing cash, transferring funds, depositing funds. So here you don't see anything about what the system internally does. It's purely about what are the events, what are the interactions from users, a bank customer, the bank itself, the maintenance person with the system. So one way to make these use cases explicit is to make a use case diagram. You could also go one step deeper, one step further, and then you create a use case description, where actually the different steps in that interaction will be described. So what will happen is that there will be a precondition, a condition that has to be met before the use case can start. There will be a post condition, which gives the condition in order to say, well, okay, we have concluded, we have finished the use case. And then there will be multiple flows, scenarios, possibly even exceptions. For instance, could be a use case like this. You often number them, you give them a name, you say which is the actor, which is the thing that's incorrect. Wording that I asked this. So you have preconditions, postconditions to see, okay, when can the use case start, when can the use case end. And then you also have a normal flow where actually the interaction between the user and the system is described possibly with alternative flows and exceptions. So if a user wants to withdraw money, it says, okay, we open the application, there's a welcome message, the person logs in, chooses an account, withdraws cash, and so on. So all those steps, the interaction between the user and the system are finalized there. Yeah. So as I said before, use case models and descriptions are very much used. Data models as well. They will focus on the elements that need to be stored in an information system, which are called entities. So entities like customers and products and so on. And then we will have many, many instances of customers, of employees, of products and so on. They will have properties like attributes. A person has a name and age, street, and so on. But we will focus on that later on in a few sessions, the session on entity relationship diagrams. And there we will see much more details on that. And the other one is a process model. Process model is a model where we describe the different steps that need to happen to provide a service, to provide a product. Also here we will see one notation, the business process modeling notation, that we will see in one of the future lectures. Yeah. Now, when we do this analysis, so when we try to understand what should that system do, I already said before, often these things are tacit. They are not well known by people, even people who are responsible for those tasks. So when you are getting these documents, when you're doing these observations, where you're talking to people, holding these workshops, often you see that some inefficiencies are there, because it's often the first time that people actually start looking at those processes in depth. Often those things, they grow organically and people do not really think about it. They're not often designed purposefully. So yeah, they are just there because that's how people thought the process should be designed. But when you are for the first time looking at those processes, it makes a lot of sense to study them and to see, are there any ways that we can make them more efficient? And so doing this analysis phase is often a good opportunity to look at them. Because, you know, in any case, you will need to do some change management. When you apply a new enterprise application, people will need to change their behavior anyway. And that's difficult in all cases. So you will need to do that exercise in any case. So why at that moment in time, when we are putting into a text, into a model, the way how an organization works, why don't we already immediately start to look at those inefficiencies and try to make them efficient first, and then only to implement them? So often during this analysis phase, people start to actually do that. And they see, well, this is strange that we work in that way. We could better do it in another way. We can swap some tasks, we can eliminate some tasks, and so on. And that's what had been called in the 90s. It was called business process engineering. Maybe today people use that terminology less, but it still happens in other terms, in other names. And the idea was coined by Herman Champion in the beginning of the 90s, and it's still very relevant today. The example that those seminal authors used was an example in Ford. So Ford's accounts payable department, where they said, okay, you can see already from the graph that it has already dated from some years ago, but the idea is still very relevant. What they saw was that they were looking at one of those parts of the supply chain, and how the financial transfers happened in that part, because they said, well, they had a purchasing department that put
or that created purchase orders to go to the vendor. Then at some point the goods were received. And then you had an accounts payable department, which basically needed to compare 3 documents. They need to compare the original purchase order. They needed to compare the receiving documents in the warehouse when the goods were received. They made up a list of all the products that were received and their quantities. And then later on, they received an invoice. And so they were comparing those 3 things. What we ordered, was it actually delivered, and was it actually invoiced? And what they see was that they need a huge amount of people to cover that process. They saw that they were not doing it too well. And one of their competitors, I believe it was Toyota, they were doing it with much less people. And so they saw, okay, well, we are maybe one of the biggest car manufacturing companies, but still, if we compare ourselves to those competitors, we see that apparently we have some inefficiencies here. And they were considering to use some automation tools to consider the use of some information systems. And so they did exactly what I just mentioned before. They were doing the analysis, the requirements, and they saw, apparently this is not working super efficiently. Let's look for some other ways to make it more efficient. And what they then said, okay, this is basically what I just described. So they observed this 3-way match. They observed this phenomenon that they needed to match the details of those 3 documents, the purchase order, receiving report, and the vendor's invoice match. And when they saw that there was a mismatch, they needed to call people to sort things out, to have another invoice, to reduce the invoice because not all parts were received, and so on. And so then they said, well, okay, let's use an information system in this case. We will not, part of them was also the digitalization experience, where they went from hard copy to digital forms. But that was not everything. They actually fundamentally changed their process. They said, well, instead of shifting all those documents and comparing them at the end, what we will do is we will keep all our data in our information system. We will still provide the purchase order to the vendor, but what we will do is we will change our process dramatically at our warehouse. We will not just receive goods, sign, and then later on take care of it. No, at the moment that the products are received at our warehouse, we will check whether the goods that have been delivered are exactly the same as the ones that we purchased. Because we will compare against our own records whether those products are exactly the ones that we ordered. And if not, they said, well, then we just do not accept the goods. We will return them, and we don't accept the order. And we tell our supplier, could be that 2 or 3 products might come later. Your loss. Go back and come back with a full order as we agreed before. And then they even said, well, guys, you don't even need to put a request for payment. We will immediately pay you as soon as we have received the goods, because we know upfront that you delivered everything that we want, and we also agreed on a price, so we can already pay. And so the whole story here is, and the fact that it's still relevant here today, is not the fact that they maybe went from digital to non-digital. The idea here to maintain is that by introducing a new system, by introducing an information system, they critically analyzed their current way of working. And they said, well, we have some inefficiencies here. There are some other companies in the market that do it in a better way, that do it in a more efficient way. And we will grab the opportunity of implementing an information system in an organization to optimize those processes. And therefore, to avoid that there is an inefficient process that we will just automate, but we will first critically look at the process, optimize it, and only then to implement. And that's the key message, which is still very, very relevant today. So basically, here in the slides, you will find a little bit of what I said, in the sense that they just didn't speed up the process. They just didn't automate the old process, but they went to a new way of working, the invoiceless processing, as it was called. The results were quite positive. The headcount, the number of people that they needed for the process went down. They had a higher accuracy. There were no invoices needed anymore. And so Hammer and Champion used that case study to say, well, what is business process reengineering now? What is BPR? Well, business process reengineering, they said, is the fundamental rethinking, radical design of business process. So what you see here, indeed, it's not fine-tuning a little bit. It's not some small details. No, it's a fundamental rethinking of a business process. They really completely changed the way how they deal with the receiving part of their supply chain. And the goal was also to not just have marginal improvements, but radical improvements. And that's the idea of Hammer and Champion with their business process reengineering thinking, where they say fundamental rethinking, radical design, dramatic improvements, and always focusing on processes. And that's something which is still, I don't say that it's necessary every time, but it's a valuable step to take when you're doing the analysis. So that means, as I said before, we don't automate existing inefficiencies. It's interesting to think about, okay, what does that mean? How does it link with the IT paradox? This might be an interesting clue to answer the IT productivity paradox, because the IT paradox said, well, it's not because you invest a lot of money in IT that you get much more productive. This is exactly what Hammer and Champy were saying. They said, well, do not just throw money at your IT project, but think wisely before you do that to make sure that you implement efficient processes. So you could have two companies investing the same amount of money in an IT system, one of them just implementing inefficient old processes, another one first redesigning their processes and then implementing the IT system. And of course, they would have different outcomes in their productivity. Yeah. That requires people to dare ask difficult questions, to think away from those old rules. And the only way to do that is really to limit yourself on processes and a limited set of processes, strategically important processes, because the idea is really to make drastic changes into them. And so the only way to do that is to really pick a few processes with a lot of leverage, and there you try to say, well, let's try to improve them and let's try to make significant changes based on them. So that means that you have a high potential impact, but they're also very risky and they also require a lot of effort, both in terms of money and in terms of change management. If you completely redesign process, there will be always a lot of people in your organization who will be very resistant and you will not like it because they have been doing this for 20 years. And now you say that they need to change. It's very human that people are not easygoing on that. It's interesting always to, of course, if you do these kind of efforts, to assess, of course, the effectiveness, to compare the situation before and after intervention and to see whether it works. Hammer and Champy said, well, basically you have two broad approaches. You can have this clean slate approach, what they call. So it's basically you start from a clean slate, literally. So you even don't look at the current processes and you just start thinking from scratch, what would be the most efficient way to realize this. And then often it helps to have some people involved with that who are not implementing the current old process because they will be biased. They will be inclined to say what they currently have. But you really start from a clean slate. Let's think wildly. Or you can say, well, no, we will start from what's there, but we will do a very systematic redesign. Every step, every part of the process, we will think about how can we radically redesign it. So those are the two main trajectories they proposed. I've included in the slides, I mean, they have written some books, Hammer and Champy, and some of them, again, they're from the beginning of the 90s. So some people say, well, they're outdated. Actually not, because what they have implemented, those ways of reasoning, they're still very relevant today. We don't have time to go through all these examples, but I've included some of them in the slides for your further understanding, for your further reading. So they have included some very well-known cases, often from international companies, multinational companies. So that might be interesting for you to take a look at. So they've included examples on IBM. They've included an example on Kodak. So I think, and also one on the Mutual Benefits Life. So some very well-known and big companies in the past decade. Maybe again, one small exercise to think about, and it's probably it's too early to have another break. Just to make things a bit more interactive and dynamic. Suppose that you're in a waiting queue. There are already systems there. There are already often information system, IT systems running there. What would be, according to you, good ways to completely re-engineer it, with or without ID? I give you like 30, 40 seconds to think about. You can even check with your neighbor. And then we will just brainstorm a little bit just to get your feeling of what this might mean, business process engineer. Come with some ideas. What could it be in the context of a waiting queue, which we probably always already all of us have experienced, and I at least always have experienced, I choose the wrong waiting queue. So how can we solve that? Think about it, 30, 40 seconds, and then we'll try to recap. Okay. Anyone having some wild ideas on how to optimize a typical waiting queue? This is basically what a lot of retailers are thinking about today, actually. So that's why I think it's an interesting question. You had suggestion? Yes, you see that there are already quite some companies or some retailers who have self-scanning. So they said instead of having a cashier, let's having the self-scanning. Some of them are also already reverting it because they say sometimes customers complain, they want to have social context. Sometimes they say, well, a lot of people, the losses in the margins of retailers are typically quite low, 2, 3, 4%. And so people tend to steal more in these configurations. So sometimes some shops have already reverted because of that. So yes, very first good suggestion, they could go for self-scanning. But then you still have queues, right? So good ID, but are there any other IDs, wild IDs? Sorry? Collect and go, yes, you could even say let's stop the shopping and just have people order their product, pick it up at a certain time, and then maybe because you avoid the peaks, you might also avoid the queues. Very good. You also had your hand up, I think. Yes, very good. And it's indeed, it goes into the line of your colleague, but indeed, very good idea. It's radical in the sense that you even don't think about having this traditional way of checking out your groceries. You pre-order them, you pick them up, so there is even no cashier anymore. So that's a very good idea. One more, yes. Yeah, go ahead. Yes, you could indeed, instead of having self-scannings, you could also give people either a device or have them their app to use to scan something, and then they can use that at the counter, or they might even go out, and once the system realizes the person with the cell phone has left, then we know the amount, and then maybe there can even be an automatic payment. Yes. So you in all different kind of degrees, but very, very good ideas. Yes. Maybe one more to end. Yes, let's see whether we still have someone else. If not, indeed, we will take the same person again. But maybe anyone else still having a wild ID? You also have but we have the same candidates again. Okay. Go ahead. No. Go. Yes. On the premium, yes. So you would deliver to even to homes as well. Yeah. Okay. Yeah, indeed. And that's also, you indeed see that some companies are experimenting with them. Some of them have introduced ideas of next hour or next day, or same hour, same day deliveries. Also there, people have experimented with that. Organizations have experimented with that. They come back from it because it's very difficult to organize, logistically speaking. But you still see that although there is a lot of technology out there, that companies are still reflecting what's the best way to organize these processes. What we also saw a few years ago is that some companies, they were experimenting with things like RFID tags to put them on the products and to see, well, maybe we even don't need an app, we don't need cashiers and whatever, we just let people put things into their basket, they run out, and based on an identification and based on all the RFID tags, we know what people took and we can make the invoice. Technologically speaking, that works, but apparently it's too costly because all those RFID tags, of course, they have their cost. And at this point in time, it's not feasible yet to counterbalance the benefits with the costs. Well, let's see your final idea. What was your? Yeah, so maybe to think about the location of those queues, maybe indeed would be an interesting one, and I haven't even seen that yet in source, so it would be a good one to think about that. So if you have a brilliant idea, I would Sell it. Sell it. All right, so very good ideas, and indeed, I like your ideas a lot because indeed, it's not only about the technology; it's also the way how you use that technology to actually reorganize yourself. Yeah, and now my presentation seems that okay. Now, Hammer and Champy, they promoted that or they proposed that idea, but then of course a lot of people said maybe that's a bit too dramatic. I mean, does it always need to be radical? Need it also need to be fundamentally? And then, of course, in the years afterwards, people came to the realization that there are all kinds of degrees of optimization of efficiencies. So you can do full re-engineering, but you can also be a bit more from the perspective of rationalizing things, slightly updating here and there your processes instead of doing something fundamentally different. Or in case that you say, well, I don't dare to take the risk, I don't have the time, I just want to automate what's there, you could also do that. Or you could even go more blunt and say, well, we will even use this IT innovation to really do a paradigm shift, to change our business model, to not only reinvent the process, but do other things, different products, different markets, and so on. And so people came to realize that, okay, business process reengineering is interesting, but actually it's one initiative that you can consider on a whole scale, high risk, high returns, but you have different degrees. You can do it in a very fundamental way, but also in a less fundamental way. Some others that were then considered in that perspective was people said, okay, let's go back to some things that were proposed in the past, like Deming in the 1950s, who said we have things like total quality management, continuous process improvement. We can also use that at the point that we introduce information systems. And their idea is, well, okay, let's not do this clean slate approach and not just forget everything what's there. Let's try to look at the current process and to see in each of the steps in each of the processes, can we improve that? The biggest difference is that a business process reengineering process is something fundamental, it's something radical, and typically you only do it once in so many years. It's a big and it's a riskful project, so you do it, and then hopefully for the next few years, you're there. Total quality management, continuous process improvement, they are more gradual, so they also allow you to do it in a more continuous way. Not a one-shot effort, but you do it in multiple steps. There is some literature, there is some guidance in academic literature on how to do that. We will briefly go through them just to give you examples of what you could do. One way to look at processes and to optimize them is look at the different steps and say, well, maybe one of those steps is maybe not needed anymore. Maybe if we have people who are asking for repayment of their costs or their traveling costs, maybe there are two people in the loop, or there are two checks that we do, one check, second check. But maybe if you see, well, the costs that are involved in the second check, maybe those costs are so high that they do not pay for catching the mistakes or catching the bad intentions of some people who ask for the redistribution of the costs. So maybe we can just remove that approval. Or we could go for a slightly different approach where we say, well, it depends on the amount that people request to be repaid. If there are small amounts, well, we will take the final decision immediately. We will immediately allow the payments or the reimbursement to happen. If there are higher amounts, bigger amounts, well, then we will first have an approval and then we will go to the final decision. So you can eliminate things, but you can also make them optional. Another way to think about optimizing processes is to execute them in parallel. Very easy, like we said in the approach chart. Sometimes you don't need to wait for task A to execute task B. So sometimes a lot of things in a company, they happen sequential just because people find it logical. But in a lot of cases, you can also think about, but can't we do some of those tasks in parallel? Might make your process more efficient. You might finish it sooner. Some shopping stores, well, they say, well, we already have well-known customers, so as soon as you order, we will ship it, and then later on we will reclaim the payment and make sure that you are that your Visa card works and so on. So sometimes you can say, let's not just do everything sequentially. Have the customer order, check creditworthiness, production of the customer order, send the invoice, and then deliver the customer order. But for instance, already provide the delivery before we actually send the customer, because before we send the invoice to the customer. Another way is if you already have tasks that have been executed in parallel, you could even go a step further and you might say, well, maybe we can even also look at the timing of that parallel activity. Maybe we can send the invoice already at the point that we did the check to worthiness, because, okay, we want to have the money as soon as possible. And so maybe we even don't need to wait until the customer order was produced. Maybe we can already send it earlier. Some customers might accept that, some not. But depending on the business context, you might consider that. You might also look at, it's a bit related to that, to the necessity of each of the tasks, but sometimes it happens that once you know the outcome of one check in a process, that you do not need to do the other checks. For instance, if people are applying for something and they need to do an enrollment, they might need to go through certain checks. Well, we know that as soon as one of those checks is negative, as soon as you are rejected on one of the checks, the business process could be, well, actually, then we know that in 99% of the cases you will be rejected. So why then still do the effort of going through check 2, check 3, if we already know that basically you already are rejected based on that? So also that is a way of optimizing processes. And again, here we're not talking about business process reengineering. We're talking about this gradual total quality management and continuous process improvement approach. And then, of course, the last option is to look, well, maybe we should not change the process itself, but let's look for technological means that allow us to still do the same task, but to automate it, to make it more efficient, to make it more quicker, to make it more cheap, purely based on technology. Yeah. So by OCR, RFID, barcode scanning, and for instance, these are, again, if we're thinking in the context of a retailer, these might be interesting technologies. But again, as stated on the slide, it's always better to first try to redesign, to optimize your process, and only then to automate it. Okay, let's have another break here, and don't be afraid. The other 5 phases that we see, we will have them very drastically short. So typically we will take 2-3 slides per phase and not so much as we did on the planning and the analysis. So we will be able to finish on time. Now we're 19 minutes past 8. So let's start again at 30 minutes past 8 for the last part of the day. All right.